Hello, Year 7. Welcome to lesson 2 of this week, which is on a diffusion investigation. As usual, first things first, please write down your title, today's date, underline them both, and I will read you the learning objectives. Today, what you're going to do is you're going to recall diffusion. That's what you did in your previous lesson. We're going to explain how temperature will affect diffusion, and we are going to evaluate a practical method. You've got practical to watch today. So once you've written down the title and date, can you please have a go at your starter, which is in your book, please? Can you write down a key point about diffusion that you can remember from last lesson? Try to use your memory before looking back. If you can get the definition of diffusion, that will be absolutely fantastic. If you can roughly remember what it means, you can write that down. That would be brilliant. If you can remember anything else about it, you can write that down too. So let's recap as to what diffusion is. So what is happening here? We've got some different coloured particles. What you need to remember is that particles in a liquid can move around and particles in a gas can move around. You might be thinking, why can't particles in a solid move around? Well, if you look back at your notes on what the particles in a solid look like, you remember they're really tightly packed. They actually can't move over one another, so they aren't able to move. They've got no space. So particles in a liquid and gas can move around, and we call the movement of one substance through a liquid or through a gas diffusion. And you can see here that the red particles have now moved through the orange particles so that they are spread out. And here is our definition of diffusion. We did this last lesson. If you remembered this from your starter activity, very well done. Diffusion is the movement of particles from an area of high concentration to an area of low concentration. So you remember last lesson, we all went and we got things that were smelly like perfumes and deodorants, and we sprayed them in the corner of one room. And there the particles were in very high concentration because we had just sprayed them over there. And eventually those particles moved, they spread out, they moved from the area where there were lots of them to where there weren't very many, and that is diffusion. Today we are going to watch a practical, and this is the equipment that I'm going to use in this practical. We are going to use a beaker which is half full of water. We're going to use some chemical called potassium permanganate. These are purple crystals, you'll see them in a minute. And we're going to use a stopwatch to time this. Can you, before we start, pause the video and draw the equipment that you are about to see in this practical so you can use this picture to help you. Draw a diagram of the equipment. So what you're going to see in the practical investigation is that the variable that we are going to change is we're going to have one beaker full of cold water and one beaker full of hot water. Everything else we're going to keep the same, but the temperature of the water is going to be different. So the first thing I'd like you to do is to think and write an idea in your book, please. What effect will temperature have on the rate of diffusion? In other words, if it is hotter, is it going to speed diffusion up or slow it down? You must write your initial idea. What do you think will happen? But it is even better if you can write an explanation as to why you think this will happen. So think about the heat, think about what it will do to the particles. What effect is that going to have on diffusion? Pause the video, write down your idea now. Well done. Hopefully you've written down an initial idea as to the effect that temperature is going to have on diffusion and on the particles. Let's now write it down in some note form with some scientific keywords. So using the knowledge that you've got from all of your particle lessons so far, please have a go at this. You've got some sentences here with gaps, and all the words that you're going to need are at the top. The word faster is there twice. That's not a mistake, you need to use it twice. So pause the video now and see if you can write those in your book with the correct words in the right place. All right, how did you do? Let's read out what happens. When a substance is heated, the particles gain more energy. This causes them to move faster. A higher temperature therefore means that diffusion will happen faster. So think back to your original idea of what might happen when you heat something up in terms of diffusion. How did you get on? This is what happens. As you give particles more heat energy, they can move faster. So if they're in a liquid, they are sliding over each other much faster, moving around more. If they're in a gas, they are moving around with more energy and they are colliding into one another more often and spreading out faster. So this should now give you an idea of what happens to diffusion. As it says at the bottom, a higher temperature means that diffusion will happen faster. Keep watching because the practical is coming up next. Make sure that you are listening to the instructions in the practical as well. So this is our practical setup, and we are today going to try to answer this question. Does temperature affect the rate of diffusion? We can test this hypothesis by setting up this equipment. I have got here 2 beakers, 2 thermometers, 2 stopwatches, and this chemical here, it's potassium permanganate. It is these crystals. And what they do is they turn a beautiful purple colour when you dissolve them into water. So we are going to set up 1 beaker with hot water, 1 beaker with cold water. We're going to take the temperature of both of those and we are going to time how long it takes for the purple colour to spread out throughout all the water. But instead of using the word spread out, what word are we now going to use? Diffuse. How long does it take for the purple colour to diffuse throughout the water? So, first things first, in any practical, you must have a hypothesis. You have to make a prediction as to what you think is going to happen. I was rudely interrupted by the pips there. So, the first thing I'd like you to do is write down hypothesis, spelled like this, and I'd like to hear your prediction. So your prediction is going to be something like, I think that diffusion will happen faster in either cold water or hot water. If you can make a hypothesis, that's brilliant. It is even better if you can explain why you think that's the case. Why do you think it's going to be faster in cold, or why do you think it's going to be faster in hot? Think back to earlier and see what keywords you can use. Make your hypothesis now. Now that you've made a hypothesis, we are going to get set up. So I have got some cold water from the tap that I'm going to test the temperature of, and we are going to get some hot water from the kettle. So let's fill that one up with some hot water. Okay, we are set up. What I've done is I've boiled some water, and this one is from the kettle. This one is just from the tap. So to make sure that we know that one is much warmer than the other one, we have got some thermometers here. This one is reading 59 degrees Celsius, and this one from the tap is 21 degrees Celsius. So this is our hot, this is our cold. To set it up, obviously in science we need to be aware of our variables, so I've made sure that we have got 200 millilitres of water in here and 200 millilitres of water in here. Remember, we are having a look at, does temperature affect the rate of diffusion? So, thinking about our variables, can you pause the video and identify, of this experiment, what is your independent variable, what is your dependent variable, and can you think of any control variables? Pause the video and have a go now. So, you should have paused, you should have had a go. Remember, the independent variable is the thing that you change, and the thing that we are changing here is
the temperature. One is hot, one is cold. So our independent variable is our temperature. Write that down if you didn't get it. If you did, very well done. The dependent variable, remember, is the thing that you measure. Now, we've got some equipment here on the table that is going to measure our result, and we are looking at the rate of diffusion. So what we are going to measure is the time taken for the colour of the potassium permanganate to diffuse through the water. Control variables, did you come up with any? What must we keep the same? Now there are a couple in this investigation, one of which I've already mentioned. We have got the same volume of water. We've got some other things that we should keep the same as well. I'm going to let you try to decide what they are as you watch the rest of the experiment. Okay, now let's start going. So we are going to put some potassium permanganate crystals into the water, and as soon as it goes in, I'm going to try my best to start timing it.
Do you want me to time it for you?
That's all right. I am aiming to use about half a spatula of potassium permanganate for each beaker. Now, those of you who are already thinking, well, there's a problem with that, good, keep that thoughts in your head, because I'm going to ask you to evaluate this experiment at the end. Right, first we are going to do, let's take this out, our hot beaker. And I'm going to start the timer. That timer's going. Look at that beautiful purple colour. And as it goes in, you can see that it's sunk to the bottom. And what we are looking for is for the colour to diffuse all throughout the water. This is subjective, and subjective means it is, at the end of the day, kind of down to opinion as to when we think it has totally diffused throughout the water. So again, with your evaluation hats on, you could be thinking about ways you could improve this experiment, because unfortunately, it's not going to be absolutely perfect and precise. But you can see there that it is diffusing, the purple colour is spreading all through the water, and we are going to have to decide when we think it has completely diffused and all of the water is purple. Okay, while our 59-degree one is working, it's still diffusing. We can still see that there's more purple colour here at the bottom than there is throughout. We're going to start the cold one as well, the one at 21 degrees. So again, I'm going to try to get half a spatula full of potassium permanganate crystals, and I'm going to put them in and start the stopwatch. I'm trying to put them in the same way as the other one. So again, you can see that the crystals have sunk to the bottom and are beginning to diffuse throughout the water. Now think back to your hypothesis. Which one did you predict was going to be faster? Did you have a reason for this? So far, do you think that you're correct? Or is your prediction changing? Right, we're going to come back to these and see what our results show.
3 hours later.
Okay, so we have come back to this now that it has diffused completely in both, and these are the results that we've got. In our 59 degrees Celsius, in our hot beaker, it took 9 minutes 43 seconds. In our beaker that was at 21 degrees Celsius, it took 25 minutes and 19 seconds. And I bet you're glad we didn't make you watch that. 25 minutes and 19 seconds. So, can you please go back to your hypothesis, to your prediction? Did you predict that the hot would be faster or that the cold would be faster? Because if you said hot, you are correct. It was faster. The rate of diffusion was higher in the hot temperature. If you can explain why that happened, you are absolutely excellent. But what we're going to do is we're going to think about the control variables in this experiment, because I would like you to evaluate this. The control variable we've already mentioned is we had to use the same volume of water. We don't use the word amount, we use the word volume, same volume of water. And of course, water isn't the only thing that we used. We also used potassium permanganate. So we should have used the same, again, we don't use the word amount, same mass of potassium permanganate. However, as you noticed, I did not weigh the potassium permanganate because it is a very, very, very small amount and it would be quite difficult to show on a balance. So I would like your suggestion. Next time we were to do this experiment, how could we make it better? There is another control variable we need to think about, which is how we introduce the potassium permanganate to the beaker. Now, you'll notice I took a spatula and I dropped it in. However, that's a bit problematic because it disturbs the water as it goes in. It doesn't all go to the same place. It would be better if we could put it at the bottom of the beaker. Now, there are ways of doing that, but I would like you to think of how we can improve that for next time. So a control variable should be how the crystals are added. Because let's say if you put one in gently and was very forceful with the other one, the forceful one, may end up diffusing faster because you're making the water turbulent, you're making the particles move more. So here are some control variables. This is what should have been the case. We were very good with our same volume of water. It was a bit harder with the same mass of potassium permanganate, and how we added the crystals is there's definite room for improvement. Can you please evaluate this practical? Keep watching. I will give you some tips as to how to do this and how to write a good evaluation. Thanks for watching.
Okay, thank you very much for watching. Now, you will have noticed in the investigation that I was asking you to think about evaluating the method that we were using. I'm going to be honest with you right now, that was far from a perfect scientific method there. There were things that could very much be improved. There were some things that were good, but there were some things that can be improved. So I would like you, please, to evaluate the method. What evaluation means is that you should identify what went well and what should be improved. The question you should always have in your head when you are evaluating something is, was this a fair test? Then you need to explain why was it a fair test or why was it not a fair test. There are some things in it that will have made it more of a fair test and some things that were not. So this is the checklist on the side that you will be marking yourself with at the end of your evaluation. So use this as a guideline, but you need to make it specific to this investigation. So talk about things like the equipment that I used. How did I use that equipment? Did I use the same amounts of things or different? Same volumes, same masses, or different? Keep watching. There are some more tips coming up. Some other ideas that may help you are here down the side. Think about things like the control variables. Were all the variables controlled, or were there some that were not? Were the measurements accurate? Was the same equipment used? Was there any human error? I was the one doing the experiment. Did I do anything wrong? And do you have confidence in the results that I got at the end? Why or why not? So now it's time to pause the video. You can go back if you would like to see the previous checklist, the previous tips. Write an evaluation. Remember what went well and what could be improved. Okay, should have paused the video, should have had a go at this. If you haven't, pause it now. Here is the checklist that you should mark yourself for your evaluation. These are quite challenging to write, so very well done if you had a really good go at this. The things that did go well in this particular investigation is that I used the same volume of water for both beakers. That's really important because that will affect the rate of diffusion. I also took accurate temperatures. I used a thermometer for this, and I made sure that the temperatures I took were accurate. However, what could and should be improved for next time is I didn't weigh the potassium permanganate. I took half a spatula, but that's not a very accurate measurement. Next time I should use a balance and weigh out the crystals. Also, I dropped the potassium permanganate on top of the water rather than put it at the bottom of the beaker. That means that some of it was diffusing down from the top and some of it sank right down and was diffusing up from the bottom, so not very accurate. It would be better, perhaps, if we could somehow put it at the bottom of the beaker, maybe by using a straw or a funnel. Didn't repeat the experiment. That's a big no-no in science. You should always try to repeat your experiments and maybe take an average result from all the data that you get. So, pause it here, use the checklist, mark your evaluation. If you didn't get top marks but you'd like to go for them, have a little go now. If you want to go for a grade 7, you should be suggesting things that you could do in future experiments that would make it better. So writing a new method and improving it. So in today's lesson, you have recalled diffusion. We've also now explained how temperature will affect diffusion. So you should be very comfortable saying that if you give something more heat energy, it will diffuse at a faster rate. And you have evaluated a practical method, something that's really challenging, but really important to be able to do. Absolutely brilliant job for doing this lesson. Now go to EduLink. There is a lovely worksheet on there for you to complete. You are absolute stars for doing this from home. Very, very well done.